Analysis of double story 2D portal frame using StatPro software. We have a diagram here which is 2D portal frame. It has a base of 3 bays and each bay consists of different dimensions. Here we have 3 meters, 4 meters and 5 meters distance between the supports and 4-meter height and 3 meters height of this frame. And we have values here. We need to get these values in the software. So let's draw this diagram in the software. Open the StatPro software, start with a new project and go to space. Select this 2D portal frame, 2D frame analysis. So set the units to meters and kilonewtons. Click on next. Use add beam option. So use finish. Here we have a span of 12 meters and we need a span of 7 meters height. In this grid we have 10 meters span and for height we have 10 meters. For height 10 meters is sufficient. For width we need to increase still 2 meters to x direction. So for that go to edit. So increase the width to 12 meters. Click on OK. Now we need to draw the frames like this. So initially click on this particular frame. We have a 4 meters distance and again 3 meters distance. And again we have a 3 meters distance apart is the first frame distance width from support to support. Next is 4 and next is 5. So let me consider the 4 grids and 5 grids. And again 3 meters, 3 meters. We have one frame developed, outer frame has been developed like this. And again switch off and switch on the grids. So click on this particular node, draw the beams from point to point. And again switch off and switch on the grid option. So draw the beams option. So you can switch off the snap node or beam option. So use beam cursor, add beam cursor. We need to add beams at this stage for 4 meters height from the base. So go to front view and we can see that we have developed with the model as required. So we have 4 support conditions and that is 4 fixed support conditions and 2 load cases. One is 40 and 20 kilonewtons. Load case is acting at the junction of the nodes. So for that first we'll create the support conditions. Before that go to general, create a property, define rectangle. First create a property 0.3 by 0.3 width and depth. Click on add. So use assign to view option to assign this property for the model. So we need to first create the supports, go to fixed and add and assign the supports to the frame. So use assign to selected node option, assign. We have assigned the support condition for the frame. So now we need to define the load cases and definitions. Click on the load case details, add and define the primary load case. Click on add. Here we have a nodal loads. I already told you that we have 2 nodal loads, that is 40 kilonewtons and 20 kilonewtons. So that is x direction we need to define. First you define the 40 kilonewtons, add. So you can see that the load are acting here, adding here. So then 20 kilonewtons add. We need to assign the 40 kilonewton load at this particular point as junction. Use this assign to selected node option, assign 40 kilonewton node. And again select this junction, use assign to selected node option and select. And scale the loads. And we can see that we have assigned 20 and 40 kilonewton loads. Go to analysis. So click on add and run the analysis. So we can say that 0 error, 0 warnings and 0 not. Go to post processing mode to get the results. So, and this is the sway action due to the nodal loads acting on these two particular nodes. To check the support reactions, so click on the reactions and you can see that reactions and values here. We have to get three reactions fx, fy and mz because this is a 2D photon frame. So that's why we are getting three values at one node and node number 10 and node number 12 and node number 8. And similarly, we can see the pending moments and we want the values of all these things. Select the frames, go to results, view values in these beam results. So check on bending moments, shear forces. So use annotate, close. And here we can see the values of these bending moments and shear forces. This is the shear force values. And similarly, if we want to see the axial forces, click on FZ. So this is the axial forces acting due to the loads. If you want to view the values of this, select the frames, go to results, select the frames by using select cursor, results, view values, beam results. You can see the axial ends, annotate. We can see the axial forces from this particular model. This is how we can find out the support reactions, bending moment and shear force for the model.